Algebra 2, Lesson 56, Finding Angles of Rotation. So there's some vocabulary and things to learn. First thing is an angle is said to be in standard position when the vertex is at the origin. So the vertex would be right here, and this is a ray. So if the vertex is at the origin and one of the rays is on the positive axis, so right here, this is positive and this is positive. The terminal side of the angle is the ray that the angle is rotated relative to the x-axis. If you start here and you rotate from 0 all the way over here, this right here is the terminal side. It's basically the ray that is formed. We went from 0 to here, it's 205 degrees. This is the terminal side. The initial side is where you always start at 0. And it's on the x-axis. This right here is a negative rotation. You start at 0 and you go backwards. So when we're working right here with this type of graph, we always move counterclockwise to make a positive rotation or positive angle of rotation. If we want a negative angle of rotation, we start at 0 and we move clockwise. This is a negative angle of rotation, started at 0, stopped here. Here's our terminal side. We end up with negative 120 degree angle. The terminal side, this guy right here, this ray, you can rotate it more than 360 degrees. So if you had a positive angle, started at 0, you go all the way around and hit 0 again, that's 360 degrees. But you can keep going as many times as you want. So first thing we're going to do is example 1, draw each of the indicated angles in standard position. 45 degrees. So 0, 90, 180, 270, and if you make it around again, it's going to be 360 degrees. Halfway between 0 and 90 is 45 degrees. We're just going to split that difference. So starting at 0, we move 45 degrees. It's our 45 degree angle. It's in standard position because standard position is when the vertex is at the origin and one of the rays is on the positive x-axis. Here's our positive x-axis. Now, negative 225 degrees. I'm going to do these on the same graph. If we want to graph a negative number, we start at 0 and we move clockwise. Negative 225 degrees. If we start here, we're at 90 degrees. Keep going, we're at 180 or negative 180. If we went here, we'd be at negative 260, which we don't want to be at. But if we go just a little bit more, it's halfway between negative 270 and negative 180. So we started at 0, went to negative 90, negative 180, negative 225 degrees. So we have now our two angles, A and B, 45 degrees, negative 225 degrees. If you weren't sure where on the graph it was, here to here is 90 degrees. This is 180 degrees. This is 270 degrees. You could just do 270 minus 225, and that will tell you where it is. It's going to be 45 degrees. We already found out 45 degree angle cuts these two in half. The next one, C, is 440 degrees. We're going to move in the positive direction, which is counterclockwise. But for this one, let's figure out where we're going to stop, because this is our first quadrant, our second quadrant, third quadrant, and fourth quadrant. We want to figure out which quadrant we're going to stop in. This is more than 360 degrees. So you can do 440 degrees minus 360 degrees. And we can figure out what's left. 80 degrees is left. So we start at 0, and we're going to go 360 degrees since we know 440 is greater than 360. Start at 0, move all the way around. We hit the x-axis again. We've gone 360 degrees. We need to go 80 more. 80 is just slightly less than 90, so we're going to keep continuing to about here. We'll draw our ray, and this right here is 440 degrees. Now we have something called coterminal angles. Coterminal angle is you're going to find one positive and one negative angle. So to do that, they'll give you an angle to begin with, like 68 degrees. And to find a coterminal angle, you either, to find a positive one, since this is positive, we're just going to have to add 360 degrees. To find a negative number, we'll just have to subtract 360 degrees. There may be instances where you start with like negative 440 degrees. If you want to have a positive coterminal angle, you're going to have to add 360, but you'd still be in the negative. You'd have to add 360 2 times. But since here we have a positive angle, to find our positive coterminal angle, it's just 68 degrees plus 360, which in this case, 68 plus 360 is 428 degrees. So if we were to graph this on a graph, we'd go to 60 degrees, which is about here, 68 degrees. To graph our positive coterminal angle, we'd start at 0, keep going around, because we want to go past 360, and we'd end up back at the same spot. 428 degrees, we'd go around one time and end up right here at the same spot. Now our negative coterminal angle, we're going to do 68 degrees minus 360. See if we get a negative number, which we will. So 68 minus 360 is negative 292. Here's our positive angle and our negative coterminal angle. If you were to go starting at 0, negative 290 degrees, you'd end up at the same spot as 68 degrees and 428 degrees. So it's the same angle, just written a little bit differently. It's like writing 2 times 2 is 4, or you could do 8 divided by 2. That's also 4. It's just a different way to write the number. Now 515 degrees, we want a positive coterminal angle and a negative coterminal angle. To find the positive, this is already positive. So if we subtract 360 from here, we'll still have a positive angle, because 515 is greater than 360. Our answer, 515 minus 360, is 155 degrees. So again, if we were to go around, starting at 0, if we went around one time, that'd be 360. And again, right about here probably is 515 degrees. Well, we wanted another angle, another way to say 515 degrees, so we subtracted 360, we got 155. If you start at 0 and go 155 degrees, again, you end up right here, same spot. Now, how to find a negative coterminal angle? Well, if we do 515 minus 360 degrees, it's still positive. So let's do minus 360 2 times. Another way to write this is 360 times 2. Okay, so we already know if we subtract 360 one time, we get 155 degrees. Now 155 minus 360 is going to give us a negative number, and that is negative 205. So our positive coterminal angle is 155, our negative coterminal angle is negative 205. Next, example 3, we're going to talk about reference angles. Reference angles are always less than 90 degrees. They come in handy when you're doing trigonometry. They're awesome when you're doing trigonometry. So let's say we went started at 0, we went 120 degrees. 120 degrees is going to be about here. So from here to here is 90. We go right here, it's going to be 120 degrees. So our angle of rotation is 120, but we're looking for the reference angle. Basically, where is the next from here, 120 to here, how many degrees is that? That's going to give us our reference angle. It is going to be 180 minus 120. So 180 minus 120 is 60 degrees. 60 is less than 90, so this is our reference angle. And like I said, they come in handy when you start doing trigonometry. I'm sorry, I didn't write these down. So we want to find the reference angle for 155 degrees, 240 degrees, and negative 20 degrees. So for 155 degrees, we are having a positive angle. We're going to start at 0, go to 90. If we go to 180, that's too much. So 180 minus 155 will tell us what we're left with. So about here is where we're going to end up. This right here is 155 degrees. Now we have to figure out what the difference is from here to here. 180 minus 155 will tell us, and that angle is going to be our reference angle. It's 25 degrees. Okay, so for a reference angle for A is going to be 25 degrees. Now a reference angle for B, you can graph it, but let me tell you, I can show you how to do this without graphing it. 240 degrees, it's going to be first, second, third, or fourth quadrant. 240 degrees is more than 180, but less than 270. It's going to be somewhere in here, in this quadrant, in our third quadrant. So what you can do is find out what 270 minus our angle, theta is our angle, and we end up with 30 degrees. Okay? So starting here at 0, it's going to be right here. It's 90 degrees for one quadrant. We have 30 degrees from 180 to here. So 0 to 90 to 180, and if we add 30 more to 180, we'll be at our angle of 240 degrees. Now, we need to figure out what the difference is between here and here. The difference for this angle, the reference angle, is going to be 30 degrees? No. You know why it's not 30? Because a reference angle is always going to go to the x-axis. You're always going to refer it back to the x-axis. So the difference between 180 and 240, that will tell us what our reference angle is. If we do 240 degrees minus 180 degrees, we have 60 degrees. That's going to be our answer. You always want your reference angle to go back to the x-axis. That's what we did here. We figured out what's the difference from this angle to the x-axis. Last one. If theta, or our angle, is negative 20 degrees, we're going negative degrees, so we're going clockwise. So that's going to be here in our fourth quadrant. We're just going to go 20 degrees, just a little ways. It's a little more than 20, but that's okay. So negative 20 degrees. We want to find out what our reference angle is. Our reference angle always has to go back to the x-axis. So our reference angle is just going to be 20 degrees. We don't have to worry about finding the difference between this angle and 270 degrees because our reference angle always goes back to the x-axis. Next, we're going to be able to use sine, cosine, and tangent, our trigonometry functions, and we can graph with this graph, 1, 2, 3, and 4. So the formula, if you're looking for this, you need to find y and r. For cosine, x over r. For tangent, y over x. you need to know what r is. It's the radius. That's what r is. The formula for it is the square root of x squared plus y squared. And I will tell you exactly how to find that. So first, it says point Q is located on the terminal side of angle theta and has coordinates -5, 12. Find the exact value of the 6 trigonometric functions for theta. So first thing you want to do, it gave you a coordinate, -5, 12. You want to find that. I am going to go, starting at 0, I'm going to go by multiples of 5. 5, 10, 15, 5, 10, 15, and same on the y-axis. It's -5 for x, so starting at 0, we go to -5, and then we go up 12 spaces. So 5, 10, about here. This is our coordinate, -5, 12. We can draw a line here, and it says to find the value of the 6 trigonometric functions. First thing that we have to do is we have to draw a little triangle. Remember, your reference angle, we always bring our line back to the x-axis and we can figure out what our reference angle is. So we went -5 in this direction, and it doesn't matter, but because it's going to turn out positive. And in the y direction, or the y-axis, we went 12 spaces. We want to find out what r is. R is your radius. It's a triangle. So r equals the square root of x squared plus y squared. X is -5 and y is 12. -5 squared is 25. 12 squared is 144. If you add them together, it's 169, and the square root of that is 13. So our radius right here is 13. Now we'll use this r to solve for sine, cosine, and tangent, and then the other 3 trigonometric functions, the reciprocals. So our sine of our angle is y over r. I'm going to write what everything is. X equals -5 and y equals 12. So y over r, our radius, 12 over 13. Once you know your radius and your x and y coordinate, you can easily solve these. The cosine of our angle, or theta, is x over r. X is -5, r is 13. And then our tangent of theta, or our angle, is y over x. You do make sure that x does not equal 0, because if 0 is in the denominator, you can't solve it. Y over x. Y is 12, x is -5. Now it's asked to find the 6 trigonometric functions. We need to find the reciprocals of these. The inverse or reciprocal of sine is cosecant, and you're just going to flip them over. You're going to have r over y, which in this case, 13 over 12. The secant is the reciprocal of cosine. It's going to be r over x, which in this case is 13 over -5. And the cotangent is the reciprocal of tangent. It's going to be x over y, which in this case is -5 over 12. These are your answers: sine, cosine, tangent, cosecant, secant, and tangent. Your homework is lesson 56, the practice questions A through I.